A short and cozy introduction to logarithm integral function. So we have Li of x as integral from 0 to x dt by log t dt. This is just basically a definition of the logarithmic integral function, and please don't be confused Li x with the other Li function, capital Li of x, which is basically the polar logarithm function defined as the sum from n equals to 1 to infinity. There's also a base of polar logarithm, which is p, and then x to the power n by n to the power p. This is the polar logarithm function, but our logarithm integral function Li of x is just defined as the integral from 0 to x of 1 by ln t and then dt. So this is the definition, and from the definition itself we can see that if we differentiate, let's say, the Li of x, we can see that the integrand rate x will again differentiate to just 1 by ln of x, yeah, and the integrand at 0 is a constant, so that will be 0, so this will just be the answer, yeah, as I have written here. Now for the other for this integral value, we shall need to do some works, yeah. For the integral of the logarithm integral function, we can use integration by parts. We get Liz. Integral of 1 is just c minus integral of, now derivative Liz is just 1 by ln of z and then g dz. Yes. Now we can make a substitution that let's say is basically x equals to ln of g. If we make the substitution, we get g equals to e to the power x. Yeah, and so g li of z minus integral of, this is just 1 by x, g is e to the power x, and dz is also e to the power x dx. Yeah, so we get g liz minus integrand of e to the power 2x by x dx. Yes, and now we also know that the ei function of g is basically integrand from minus infinity to g of e to the power t by t dt. Yeah, from this definition we can see that actually the derivative of ei of g will just be, okay, hold on for some time, hold on, yeah, ei of g, and then this is just e to the power z by z. Yes, so you can see that the integral of this thing will just be ei of g. Yeah, so what we can do is you can make here 2x, and then also over here 2, which can go inside differential, so d of 2x. Yeah, so we can see that this is also the same integral. We can let g as 2x, and yeah, e to the power z by z dz will be there. So this is g li of g minus ei of 2x. Yeah, and we know that x is just ln of g, so it will be g li of g minus ei of 2 ln of g, and this will be our answer for the integrand of li of g. G li of g minus ei of 2 ln of g. Yeah, so we found the integral, we found the derivative, and we used the definition as well. Now let's just go to the recap. So similar to the previous polar logarithm function, not really similar, but yeah, we got a small logarithm integral function, which was basically integral from 0 to x of 1 by ln dt. Yeah, the derivative was simple, just the integrand and then differential, so it will come same, and over here it's constant, so 0. For the integral we use integration by parts, and then I use substitution. Now this we use the definition of the exponential integral function, and we got the answer. Yeah, so that was it. Hope you enjoyed the video. Thanks for watching, and look forward to seeing in the upcoming videos too.